Okay, so today, class, we are going to be looking at graphing quadratics in standard form. So we've been talking about finding all these important pieces of quadratics, whether it's the vertex, whether it's the intercepts, right? Does it open up? Does it open down? We've looked at graphing in the vertex form. Now we want to take that a step further and say, can we graph a quadratic when it is given in the standard form that we've been looking at? Okay, so we're taking quadratics and we are going to graph in standard form. Sorry, it's a terrible S. So if we want to graph in standard form, the key to graphing any quadratic is that we want to have 5 points. And we know that the middle point, the very middle point of the quadratic, is going to be the vertex. So when we are looking at a table, no matter how big you make your table, you want to have 1, 2, 3, 4, 5. Now, I have an extra space in the table in case you mess up and you need to try another value, one got too big, something like that. Okay, but for the most part, we are talking about making 5 points, where in the very middle of the table is going to be our vertex. And we know that to find the vertex, we need to use the formula negative b over 2a. And for the y, we need to plug it back in. So we want to do those exact same steps that we have been doing up until this point. So to find this vertex, our very first step is going to be to do negative b over 2a, which means we need to find a, b, and c. So if we're looking up here at this original problem, what does a equal? We should have picked 1. Okay, what does b equal? 2. And what does c equal? 1. Now we need to plug this into negative b over 2a to find that x value of our vertex. So if we plug this in, we're going to say negative 2 over 2 times 1. And what number does that give us? This gives us negative 1, right? Negative 2 divided by 2 is negative 1. That is the x value of our vertex. So that is the number we are going to put in our x column. Now, to find the y value that goes with it, we're going to do exactly what we've been doing to find the y value all along. We are going to take this negative 1 and we are going to plug it in for x in both locations. So just like before, because it's negative 1 squared, that needs to go in parentheses. That's a squared. Plus 2 times negative 1 plus 1. So I want you to pick up your calculator, right? And just like we've been talking about, make sure you put that negative 1 in parentheses and type it in all the way across just like you see it. And what value do we get out? We should have got 0. Okay, so now we know we have a vertex at negative 1 comma 0. So we are going to take that and plot that point on our coordinate plane. So this is the point negative 1, 0, which is right here on our graph. Okay, now we want to find some values above and some values below. So we are just going to count on this x column like we're counting on a number line. So we're going to go in this x column here, and we're just going to count up and down from negative 1. So if I'm going negative 1, negative 2, negative 3, so negative 3, negative 2, negative 1, 0, 1. Right? I'm just making those go in numerical order. If you don't feel as comfortable doing that, you can always take negative 1 and then subtract 1 and then subtract 1 more. Or take negative 1 and then add 1 and then add 1 more, right? And just it will give you out the numbers. So just like we found 0 by plugging in negative 1, we now want to do the exact same thing by plugging in each of these values. So now I'm going to take negative 3 and I want to plug it in for x on both of these. So I'm going to say negative 3 squared plus 2 times negative 3 plus 1. So again, let's plug that into your calculator. And what value do you get out? We should have said 4. Now we're going to repeat the process over and over. So now we're going to plug in negative 2 squared plus 2 times negative 2 plus 1. What value do we get out? We should have got out 1. Okay, we already did negative 1, so now we are going to plug in 0. 0 squared plus 2 times 0 plus 1. What value do we get out? We get out 1. And then finally, plug in 1. What value do we get out when we plug in 1? We should have got out 4. Now, it is not a coincidence that these values here are the same and that these values here are the same. Remember, a parabola is symmetric. So those values that are happening in our y value, as long as we have found the vertex correctly, should be the same. If we ever get that those numbers aren't the same, that means we did something wrong. So to finish graphing this parabola, we are just going to plot the rest of these ordered pairs. So this is really an ordered pair, negative 3, comma 4. So I'm going to go left from the origin, 1, 2, 3, and then up, 1, 2, 3, 4. Okay, and now I'm going to go left from the origin, 2, and up 1, because this right here, let me make my pen a bit bigger. This point right here is the point negative 2, positive 1. Now, I've plotted this point, I plotted this point, I already plotted the vertex. So now I'm going to plot the point 0, comma 1. So I'm going to start at the origin and then go up 1. Okay, and then I'm going to plot the point 1, comma 4. And this right here, if I just draw in my parabola, is then our graph of y equals x squared plus 2x plus 1. So let's look at another example here. Let's say we want to graph y equals, it's a little bit smaller so it all fits, negative x squared minus 3x plus 2. So again, we are in standard form. So we're going to start by finding our vertex. So remember, we need 1, 2, 3, 4, 5 boxes. Again, that extra box is there because in class we would print this out and we would do some more work with it, but we have e-learning, so here we are. Okay, so if we're going to find that vertex first, we're going to start by doing negative b over 2a. So first we need to then find a and b. So what does a equal in this problem? We should have said negative 1, and b in this problem is negative 3. So now if we plug this in, we're going to say the negative of b. So the negative of negative 3 actually ends up being a positive 3 over 2 times negative 1. Okay, so 2 times negative 1 gives us a negative 2. So we'll have 3 over negative 2. Now, my guess is that for the majority of you, working with that fraction isn't where we're most comfortable. And so it's totally fine if you want to turn this into a negative 1.5. Now, the option is up to you. You could decide to keep counting by 1/2 and do negative 2.5 and negative 3.5. Again, for the majority of my students, avoiding those decimals and fractions as much as possible is usually the preference. And for my students, that then means, okay, can I get away from that decimal value? So if I look at a number line, and I say that this is negative 3, negative 2, negative 1, 0, 1, and I plot my point of negative 1.5, that's right here on my number line. So instead of having to count and go all the way to negative 2.5, let's just go to the value to the right and to the left of it that are no longer decimals. And we could do that. So our next value here would be negative 2 and negative 1. Now, if we have that info, what values do you think we would use next? Hopefully we picked 0 and negative 3, right? If we're making this next jump to the next value, we would go to 0 and we would go to negative 3. So we're then going to take these values, and just like we were talking about, we want to plug these all in for the x squared. So be careful when you plug this in. you want to take the negative that was already part of the equation, and then the negative that is part of the number, and that's what goes in parentheses squared. Okay? You don't want to just say two negatives make a positive because that's not what's happening in this situation. So we'll have -3 times -3 plus 2, right? This is really the -3 times -3 plus 2. Okay, so again, I want you to put this in your calculator. Make sure you type it exactly how you see it, and then tell me what value you get out. We should have got out 2. Okay, next we're going to plug in -2. So now go through and plug in -2 and tell me what value you get out. We should have got out 4. Okay, again, for this next one, we want to go through and we want to plug in -1.5. So I want you to go through and plug in -1.5 and tell me what you get out. Okay, and hopefully we got out 4.25. Now, using the rule that we said before about these being symmetric, it's always still wise to check. But what value do you think we should get when we plug in -1? We should have said 4, so let's just plug in -1 and check. So if we do negative and then we do the parenthesis -1, close parenthesis squared, -3 times -1 plus 2 equals, we do in fact get out 4. So then plug in 0 and tell me what value you get out. Here we should have got out 2, which again matches because right here we want that to be a 2. So we know that this is a parabola that should be opening down, right? A is -1, so that means a downward opening parabola. So let's plot these points and see if that's what we get. So I'm going to plot the point -3, +2. So I'm going left 3, up 2. Now we're going to plot -2, +4. And that's up here. Now this next point, we are going to have to approximate a little bit. We can't change the location of the vertex. So we're going -1.5, comma 4.25, which is going to be up here in between. And somehow I don't want that. It's going to be up in between right here. Okay, then we want -1.4, which is going to be here, and 0, comma 2, which is going to be here. And again, this is still our parabola opening downwards, and that's what we get for our graph. Let's take one look at one last problem here. Y equals x squared plus 8x plus 11. If we want to graph this, what should we do first? We definitely need to start by finding the vertex, right? And that's going in our third box down here. What formula do we use to find the vertex? To find the vertex, we use x equals -b over 2a. So I want you to use this formula and the values from this equation and tell me what we get for our x value. We should have said -b, which is -8, over 2 times 1. So -8 divided by 2 is a -4. So our x value here should be -4. So now we want to fill in the rest of our values for the table. Okay, so when we fill these in, we're just counting in numerical order. What values should we have for our table x values? When we're counting both directions, we have a -5, a -6, a -3, and a -2. So those are the values we should have for our x values. What do we want to do next? Our next step is that we're plugging in each of these values to get their y values, right? So when I'm plugging in -6, I'm going to say -6 squared plus 8 times -6 plus 11. So if you put that in your calculator, what value do you get out? We should have got out -1. Okay, so when we plug in -5, what value do we get out? We should have got out -4. When we plug in -4, what value do we get out? Here we get out -5. When we plug in -3, what value do we get out? We should have picked -4. And when we plug in -2, what do we get out? Here we get out -1. And these are correct, right? Because we have that nice symmetric look. What do we need to do next to graph this parabola? We should be plotting the ordered pairs from this table. So we want to plot our first pair of -6, -1. So if I plot that point, I'm going to go left 6 and then down 1. Next, I'm going to plot -5, -4, followed by -4, -5, followed by -3, -4, and then -2, -1. And here is the graph of this quadratic.